Hi everybody. In this lesson we're going to cover the first part of section 5.2, which is basically a few more rules about exponents. So let's get started. What are we going to talk about today? Well, we're going to talk about how to simplify powers of expressions by using the properties of integer exponents, and once again recognize which property we need to use in certain situations. Now, in our previous section, we learned about these 5 rules. The exponent, the rule with the exponent being 1, the fact that the exponent being 0, which is always equal to 1 if a is a non-negative number, the product rule, the quotient rule, and the fact that negative exponents can be written as reciprocals. Now we are going to introduce the product rule. And to do that, let's consider the following. Consider the expression 2 squared to the 5th power. Now, since the 5th is outside the grouping symbol, that is basically says that I want to multiply 2 squared by itself 5 times. So that would be 2 squared times 2 squared times 2 squared times 2 squared times 2 squared. Whew. All right. And now that I've done that, I can go ahead and use the product rule. And that would be 2 raised to the 2 plus 2 plus 2 plus 2 plus 2 power. And of course, if we add all those up, we will have 2 to the 10th. But also notice that that's also equal to 2 to the 2 times 5 power. And notice that we have a 2 here and we have a 5 there. And of course, all this is equal to 1024. So it turns out that we could actually rewrite we could actually express this expression as 2 raised to the product of 2 and 5, or 5 times 2, which once again is 2 to the 10th. Well, that's what we're doing here. We're saying that any a raised to the nth power, that quantity multiplied by itself n times, is actually equal to the base a raised to the product of these 2 exponents. And it does make sense, because if you think about it, we are multiplying a to the mth by itself n times. As a consequence, the equivalent power is going to be m times n. Now, what does this look like in problems? Well, here's one right here. Here we have x squared raised to the 4th power. Applying the product rule, we would have x raised to the 2 times 4 power, which will be equal to x to the 8th. And that's it, you're done. Now let's take a look at this one right here. This is y to the negative 7th, the entire thing squared. Using the product rule, we would have y to the negative 7 times 2, which is equal to y to the negative 14th. Are we done? Well, of course not, because we have a negative power up here, and we don't like negative powers. Well, you might like negative powers, but I don't. So we need to rewrite this as 1 over y to the 14th. And once we have it in terms of a positive power, we are good to go. And then the last in this section is 2 cubed raised to the negative 2nd power. Using the product rule, that would be 2 raised to the 3 times negative 2 rule power. That can be re-expressed as 2 to the negative 6. Using the reciprocal to remove the negative exponent, we would have 1 over 2 to the 6, which would be 1 over 64. And there you are. Now, here is another rule that we have, which has to deal with powers of a product. If you have the product of 2 bases being raised to an integer power, then that can be simplified as the first base, a, raised to that power, times the second base, b, raised to that power. That's what we have here. Further, if those bases were actually raised to integer powers, and that product was raised to an additional power, then that is equal to a to the k raised to the nth power, which would be a raised to the k nth power, b to the m raised to the nth power, which would be b raised to the product of m and n. So if you notice here, the n is operating on the k, the n is multiplied by the k, and the n is also multiplied by the m. So it has a distributive property about it. But it might make more sense in examples, so here we go. Here we have -7 times a times b squared raised to the third power. So we actually have three bases, 1, 2, 3. So we can rewrite that as -7 cubed times a cubed times b to the 2 times 3 power. -7 cubed happens to be -288. Then we have a cubed followed by b to the 6. And that's it. We are done for that particular problem. Now we have x squared y to the -3 all raised to the -4th power. Once again, using our product rule, we're going to have x raised to the -4 times 2 power times y raised to the -4 times -3 power. And that will give you x to the -8 times y to the 12. And that will give you y to the 12 divided by x to the +8th. Once again, moving this down to the denominator so we can change the coefficient there. And for our last problem, we have a b squared, that quantity raised to the -5 power. Once again, using the product rule, or using the power rule, my apologies, we have a to the -5 times b to the 2 times -5. That will give me a to the -5 times b to the -10. Of course, we can't have negative powers, so we're going to take the reciprocals, and that will be 1 over a to the 5th, b 10th. And there we go. Now let's talk about negative numbers and exponents. Particularly, take a look at this. This is -x squared. You can write this explicitly as -1 times x squared. And notice that the square term only operates on the x. It does not operate on the coefficient, whether it is expressed or implied. As a consequence, this is equal to x squared, or -x squared. Now take a look at this one. This is -x enclosed in grouping symbols squared. Now this operates with the power rule. This will be equal to -1 squared, which by the way is 1, times x squared. So this would give x squared. So without the grouping symbols, the exponent only operates on the variable that it is next to. With the grouping symbols, then it operates on everything inside the grouping symbol. And this brings us to the power rule as far as a quotient is concerned. And it really is no different than the power rule as far as a product is concerned. In the product, we have a times b raised to the nth power, and the exponent operates on the a and it operates on the b, which gives you a to the nth times b to the nth. Well, here we have a divided by b raised to the nth power, and the exponent still operates on the a to get a to the nth, and it still operates on the b to get b to the nth. So there really is not that much of a difference. It's just that the form is different because we're dealing with fractions and divisions and not products. Similarly, if you recall, if we had a to the k times b to the m raised to the nth power, the exponent n operates on the k, which would give us a to the nk, and the exponent n operates on the exponent m here, which will give us b to the nm. Well, the same thing happens here. The n operates on the k to give us kn, and it operates on the m to give us mn. So there really is no difference between the two, except for the fact that we're dealing with ratios or division instead of just straight products. What does this look like in terms of a problem? Well, here we go. Here we have x squared, x divided by y squared, the quantity raised to the 5th. And that will be using the quotient rule, x to the 5th divided by y to the 2 times 10th, 2 times 5, my apologies, which will be equal to x to the 5th divided by y to the 10th. Next, we have negative 2a over b cubed, the entire thing, well, cubed. So we have 3 bases. One base is negative 2, the next base is a, the third base is b. So that is going to be negative 2 cubed a cubed divided by b cubed 3 times 3 to the 3 times 3 power. 3 times 3. All right, well, negative 2 cubed is negative 8. Negative a cubed is, well, a cubed. And then b to the 3 plus 3, 3 times 3 power is b to the 9th. And that will give us, well, there you go, it's negative. Sorry about that, it appears I hit the wrong button, but nonetheless, to simplify this, you will have negative 8 a cubed over b to the 9th. Okay, moving on. Okay, now here we have an expression, and there's actually 2 ways to solve this. The first way is we could actually solve what's inside the grouping symbol and then apply the power rule. The second way is, well, we can actually apply the power rule and then simplify. So first we're going to go ahead and simplify, and if we do, we have a y divided by y squared, and that could be rewritten as 4x cubed over y, because this one y will cancel out one of the 2 y's there. And that entire thing will be raised to the 4th. And that would be equal to 4 to the 4th, which is 256, times x to the 4 times 3, divided by y to the 4th. And that would be 256. X to the 12th divided by y to the 4th. Now the other way is to apply the power rule first and then simplify. And if we did that, we would have 4 to the 4th times x to the 3 times 4 times y to the 4th divided by y to the 2 times 4th. And that would be 256. X to the 12th y to the 4th divided by y to the 8th. Now we could simplify the y's, and that would give us 256 x to the 12th over y to the 4th. And that would be that solution. So once again, one answer, but 2 ways to arrive at that answer. Now for this particular problem, I'm just going to go ahead and do the first way because usually the nature of the problem will determine the best approach, and the way this problem is done is probably better to the way this problem looks. It's probably better to simplify the terms inside the grouping symbols before applying the power rule. Why? Well, look, you have an m squared divided by m. That's just m. And then we have an n squared divided by n, which is just n, and all of that is cubed. And now we can apply our power rule, and we will have m cubed, n cubed, and we are done. Okay, the other thing we want to talk about, we've talked about it before, is just to notice that if you are taking the reciprocal of a fraction changes the sign in any exponent of that fraction. Specifically, 1 over a to the m, n, b to the mth is equal to a to the negative n times b to the negative nth. 2 to the negative 2 is just 1 over 2 squared, which is 1/4. 1/3 to the negative 2 is just 3 squared, which is 9, and so on. So, moving any term from the numerator to the denominator or vice versa changes the sign of the corresponding exponent. Here we have b to the minus mth. If you move that to a numerator, it becomes positive n. That should be a plus right there as a typo. If I have d to the minus p in the numerator, bring it to the denominator, should make it a d to the plus p. And what does that mean in terms of problems? Well, here's one. Here we have 6x squared y divided by y cubed. And there's a variety of ways to approach this. We can first simplify what's inside the grouping symbol. For me, I like to get rid of my negative exponents first if I can. So I can do this by rewriting this as a reciprocal, and then it'll be reciprocal squared. So this is equal to y cubed divided by 6x squared y, the entire thing squared. Okay, now I can simplify. Here I have a y3 in the numerator, a y in the denominator. That would be y squared in the numerator. So I'll have y squared over 6x squared, the entire thing squared. And now I can apply the product rule. That will give me y to the 2 times 2 in the numerator, 6 squared times x to the 2 times 2 in the denominator. And that will be equal to y to the 4th divided by 36, x to the 4th. And here is another one. Now here I have a negative 2 in the numerator, and kind of the way I operate, I want to deal with this first. So I know since it's a negative 2 in the numerator into the negative 2 in the numerator, I can rewrite that as n squared in the denominator. So this will be 2m cubed divided by this down here, n squared, n cubed, the entire thing squared. And that will be 2 squared, m to the 3 times 2. Oh, wait, hang on. Wait, before I do that, there's one more thing I want to do. Hang on a second. I almost forgot. Now, before I do what I was about getting ready to do, what I want to do is I want to simplify the denominator here. Here I have n squared times n cubed. I can rewrite that as n to the 5th. So I'll have 2m cubed divided by n to the 5th, the entire thing squared. And now I can apply the power rule. That will give me 2 squared m to the 3 times 2 power divided by n to the 5 times 2 power. And then that will be equal to 4 m to the 6 divided by n to the 10th. And there you go. And then for my last example, this is actually one of your homework problems. Now notice I have an expression here raised to the negative 1st power, and then a different expression here raised to the negative 3rd power. So they're kind of like two different bases, almost like composite bases to a certain degree. But this is raised to the negative 1st power. That means I can rewrite that in the denominator to the 1st power. 4x squared y to the minus 2. And since it is to the 1st power, I don't need to do anything there. And then up here, I will have 2. And then over here, since this is to the negative 3rd power, it will be to the positive 3rd power in the numerator. So this will be 2x to the negative 2y, the entire thing cubed. Now, it might make, since these are still actually two different bases, it might make sense to apply the power rule to this. And if I do, I will have 2 cubed, which is 8, x to the negative 2 times 3, y cubed, divided by 4x squared y to the negative 2. All right, well, 8 divided by 4 is 2, so this will be 2x to the minus 6 y cubed divided by x squared y to the negative 2. Okay, now the 2 stays up here. Here I have x to the negative 6. That can be an x to the negative 6 in the denominator. And I have y cubed. Here I have x squared. This is x to the positive 6, my apologies. And then I will have y cubed in y squared in the numerator. And now I can combine. Y, using the product rule, I have y cubed times y squared, which is y to the 5th, so that gives me 2y to the 5th. And then in the denominator, I have x to the 6th times x squared, which will be x to the 8th. And there you go. We are done. That's all I have as far as lecture material is concerned, and just bear with me for a couple of seconds and I will get Hawks up and running. Okay, so here is our first problem, and this one is -3 to the 4th. Now remember, the 4 operates on the 3. It does not operate on the implied -1 coefficient here. So this is going to be equal to -3 to the 4th, and that will be equal to negative, and it turns out that 3 to the 4th is 3 times 3 is 9, times 3 is 27, times 3 is 81. So this should be -81. Excellent. You may be inclined to think that this is positive 81, but that would only happen if it was if you were given the expression -3 in grouping symbols to the 4th, and indeed it would be 81, positive 81, but we were given this, so it's that. Okay, so here is one where we need to use the power rule. Here we have 5 times -5y squared cubed. Now notice that the 5 is not inside the parentheses, so that actually just stays right where it is. And then we need to deal with the rest of them. So we will have -5 cubed times y to the 2 times 3. Okay, well, keep our 5. -5 cubed is -125. And y to the 2 times 3 is just y to the 6. All right, -125 times 5 is just simply -625. And that should be our answer. And there we go. Okay, that problem is pretty much the same. Well, let's actually do it anyways. Here we have 7 times b to the -3, the entire thing squared. Okay, well, once again, the 7 doesn't, we don't do anything with the 7. So we'll have 7 times b to the -3 times 2, which will be 7 times b to the -6. And that will be, now remember, this is a negative power. We can't have that, so we write this as 7 over b to the 6. And that should be our answer. Awesome. Here's one that operates on 2 bases. So here we have 3 times 2xy to the -1 to the -1st power. Now, once again, the first thing I want to do is I want to deal with this monstrosity right here. And since this is to the -1st power, I'm going to rewrite all this in the denominator. And that will give me 3 over 2xy to the -1st power. Okay, so that takes care of this part. Now I have a y to the -1 power. That should be -1. And so since that's the -1 power, I need to move that to the numerator, and that will give me 3y over 2x. And that should be my answer. All right. This one might be worth doing. This one is 3x squared over y squared, the entire thing squared. I think the best thing here, well, I'm sorry, over y to the -2 power. I think the best thing here is to go ahead and do the power rule first. If you do, you will have 3 squared times x raised to the 2 times 2 power divided by y raised to the 2 times negative 2 power. And that will give us 9x to the 4th divided by y to the negative 4th. Now y to the negative 4th can be written in as y to the 4th in the numerator, and that will give us 9x to the 4th, y to the 4th. And there we go. Let's go ahead and do this one. Okay, so this was the kind of problem where we might want to simplify what's inside the grouping symbol first. We have a cubed, b cubed, over ab, the entire thing cubed. Now we could just go ahead and do the power rule, but I think it might be easier if we just simplify what's inside the grouping symbol. Because we have a to the cubed divided by a, which is a squared, and we have the same thing for b, which will give b squared. All that cubed. And then we can use the power rule. That will be a to the 2 times, that's not a to the 2 times 3 times b to the 2 times 3, and that will give a to the 6, b to the 6. Okay, so here we have 4x cubed y to the minus 1 raised to the negative 3rd power divided by 2x to the negative 1 y raised to the minus 2 power. Well, notice here that this is raised to the negative power, negative 2nd power, so we can have in the denominator, so we can actually place that in the numerator raised to the 2nd power. That would be 2x to the negative 1 times y squared. And then here we have this term raised to the negative 3 power in the numerator. So that will be the same thing raised to the 3rd power in the denominator. That would be 4x cubed y to the minus 1, the entire thing cubed. Now we can use our power rules. Using the power rule in our numerator, we will have 2 squared times x to the minus 1 times 2 times y squared. And then using the power rule in the denominator, I will have, and that is a 3 there, if I'm not mistaken, I will have 4 cubed, I will have 4 cubed times x to the 3 times 3 times y to the negative 1 times 3. And then that will be equal to, well, 2 squared is 4. X to the negative 1 times 2, that is just x to the negative 2. And we have y squared. Then over here, I will have 64. X to the 3 times 3 is x to the 9th. And then y to the negative 1 times 3 is y to the negative 3. All right, so 4 divided by 64 is just 1 over 12. No, I'm sorry, 1 over 16. Okay, then we have x to the 2 in the negative 2 in the numerator, which becomes x squared in the denominator. X to the 9th. We have y squared up here. And then the y to the negative 3 in the denominator becomes y cubed in the numerator. And we get y to the 5th divided by 16, x to the 11th. And let's see if that works. And there we go. And that is all I have for this particular lesson. If you have any questions, once again, please feel free to contact me. This is Bob Boyle, signing off.